Welcome to homework.
All right, for problem 77, this is a two-step reaction, and we're going to need to balance both of them. So that's where we will start. Okay, so we start with the lead 2 sulfide, which reacts with oxygen gas, and this is step 1. And that gives us the lead oxide, the lead 2 oxide, and sulfur dioxide. So we want to balance this one first. The first thing you want to do here is count your atoms on each side and see if you have the same. We don't have the same. We have 2 oxygen here and 3 oxygen here. So what I want to do is I first want to put a 2 here because that will give me an even amount of oxygen. So now I have 4 here and 2 here, but now I have 2 lead here. So I'm going to add another 2 here, and that's going to give me 2 lead. So the lead's now balanced, but the sulfur isn't. So I need a 2 here. Perfect. And that now leaves me with 4 oxygen plus 2 oxygen equals 6 oxygen. So if I put a 3 here, now I have 6 oxygen on this side, and step 1 of the reaction has been balanced. So for step 2 of the reaction, we have the lead oxide, which is what reacts with more lead sulfide, or the galena, as they say in the problem. And this gives me the elemental lead. And finally, the sulfur dioxide, or more of the sulfur dioxide. So to balance this one, I can already see that there's 2 lead on this side and only 1 lead on this side. There's also 2 oxygen on this side and only 1 on this side. So I'm going to balance my oxygen first, just because this lead is alone, so I can add as many as I want, even or odd, at the end. So 2 lead, 3 lead now on this side. And now the oxygen's balanced and the sulfur is balanced. So if I put a 3 here, now I have 1, 2, 3, 1, 2, 3. It's balanced. Perfect. Okay. So for part B, we're going to add these equations together to give us our final kind of our reaction that takes away all of the intermediate steps. And I'll show you that in a second, how they cancel out. So if I look here, I have 3 of the lead sulfide, and I have 2 lead oxides and 3 moles of the oxygen gas, and that gives me 3 sulfur dioxides, 3 moles of elemental lead, and 2 moles of lead oxide. So right here, I can see that I have this on the lead oxide on one side and on the other side. So I can cancel these ones out because they balance each other out, kind of thing. And same with this here. If I write this out fully, you can see that we have 3 moles of each compound. And basically that means that I can cancel that 3 out, and it can just turn to 1. So I can get rid of this 3 because we have an equivalent amount of each on both sides. And this leaves me with 1 mole of each thing here, of each compound, I should say. Okay. So this is my final reaction here. Oh, I didn't mean to put a 3 there. Okay. And now for part C, all we want to do for it asks how many metric tons of sulfur dioxide form for every metric ton of lead obtained. So if you look here, it's a 1-to-1 molar ratio, but I'm going to erase this after. Okay, so 1-to-1 molar ratio of the, 1-to-1 molar ratio of the sulfur dioxide and the lead. So for every 1 molar or 1 mole of the lead, I get 1 mole of the SO4. I didn't mean to say SO4. SO2. Okay. Yep, that is the problem. Perfect.